Hi everyone, welcome to today's class again. Like I did promise in my previous class where I did an expansion of your 2x plus 3y to the power of 4. Okay, that power is a bit smaller compared to what we have here, and I promise that I'm going to release a video that we have a higher power. So how do we expound this question on the board? How do we expound it? The question reads, expound bracket open iota minus 1 close bracket all to the power of 12. Now, if we had plots here, the question would have been easier, but here we have a minus sign. So how do we expound this? Yeah, I'm going to show you how to expand it with ease. Okay, so if you're new here, this is Online Maths TV where we learn mathematics all the time. If you're not subscribed, do well to subscribe this channel so that you get notified whenever we roll out a new video. Okay, like the one you're about to watch here now, you will definitely learn something from this very one. So without much waste of time, let's go to the board. Okay, so here we take our selection. Good. The question here, we have the bracket open iota minus 1 or to the power of 12. Now let's take a look at our binomial theorem. Now, if we have a system, for instance, we have your x plus y or to the power of n. How do we expound this? We know that this will give us here the summation as k goes to 0 from n into n combination k, then into your x to the power of n minus k times y to the power of k. We all know this. This is our binomial theorem to expound this, right? Here, all we need to do, this very expression here, is to get the coefficient, which automatically will give us, if we are to open up this, so we're going to have this as your k goes to 0 from n, then n factorial all over n minus k factorial times k factorial into our x n minus k, the dot y to the power of k. This is what we're going to have. The essence of this place here now is where we are going to bring in Pascal triangle. The Pascal triangle will enable us to get all the coefficients to all the terms we are going to have here. And at the same time, we are going to look for the power of our iota from 0 to 12 also. Okay, so now with this now, this may take us a longer time to get the coefficient to all the 12 roots here. And so I will introduce Pascal triangle in place of this very one here now. Now, if you look at our x, the power of x from here will be decreasing. Meanwhile, the power of y will be increasing. Okay, so this one will be decreasing by minus 1, while this will be increasing by plus 1. So this exponent here is what we're going to use Pascal triangle to get the coefficient. So let's erase this and draw up our Pascal triangle before we go into this. So for our Pascal triangle, from the power of 0 to the exponent of 12, we go to have 1, the 1, 1, the 1, bring this, 2, 1, okay, 1, bring this, 3, 1, 4, 6, 4, 1, 5, 10, 5, 1. All right. Okay, so this is our Pascal triangle with this exponent in view. Okay, so this is the 12th exponent. So this is what we're going to take here now. The bottom column is what we're going to take for this expansion here now. So let's go into expanding this now. Now that we've gotten this column now, this column for our Pascal triangle, this is what we're going to use here now. So with this, how do we now expand this? We are going to rewrite this expression first to bring in a plus sign here. So this will also be written as bracket your iota plus, okay, bracket open minus 1 close bracket. Because we're having a bracket in here, so let's resolve to using square bracket here. Square bracket all to the power of 12. So how do we expand this now? Very easy. So let's erase this part of our Pascal triangle here so that we have enough space for here. So from here, we now have this. This now implies the square root of our bracket open iota there plus, here we have minus 1 there, or into our 12th will not be equal to, let's put this guy in bracket too, will not be equal to what? The first coefficient here now is what? Is 1. So the second one, that is what we're going to follow. But let's erase this part of our Pascal triangle so that we have enough space to expand that. All right, but before we go ahead to expand this, remember we have iota. So let's also look at the power or the value of iota from 0 to 12th power. So for our iota to the power of 0, this will give us 1. Okay, this will give us 1. The iota to the power of 1, this will give us iota. Iota to the power of 2, this will give us minus 1. Iota to the power of 3, this will give us minus iota. Iota to the power of 4, this will give us 1. Okay, the iota to the power of 5, this will give us iota again. The iota to the power of 6, this will give us your minus 1. Okay, the iota to the power of 7, this will give us minus iota. Good. The iota to the power of 8, this will give us 1. Okay, the iota to the power of 9, this will give us iota. The iota to the power of 10, this will give us will this give, okay, minus 1. Yes, will give us minus 1. The iota to the power of 11, this will give us minus iota. And iota to the power of 12, this will give us positive 1 again. Okay, because you know our iota, generally we know that iota is equal to the square root of minus 1. Is equal to the square root of minus 1. So if we follow this thread, this is what we're going to have as our iota. Okay, so with this now, let's go ahead. We want to make use of this and this to open up this guy here now. All right, so let's go step by step. Now, we said this guy will be decreasing. So the coefficient here is 1. So no need writing that 1. So we're going to take iota to the power of 12. Meanwhile, minus 1 will be to the power of 0, which will now give us will not give us 1. Okay, because anything to the power of 0 will give us what? 1. Okay, so this guy will give us 1. Remember, we are treating this minus 1 as an entity, the iota as an entity. So we now go to the next term. Here the coefficient is what? 12. So we have here 12 into our iota, which is times. Yeah, iota automatically will turn to what? 11. Then our minus 1 here will not be bracket minus 1 or to the power of what? 1. We go to the next term. So we have here 66, okay, into our iota. This time iota will now decrease to 10 and minus 1 to the power of 2. Then again, plus, the next term is 2220. Our iota will be 9. Bracket minus 1 to the power of what? 3. There, plus, the next term is 4, 9, 5 into our iota 8, the bracket minus 1 to the power of 4. There, plus, what is the next coefficient? 792. So we have 792 into our iota. Iota this time will be 7. Then bracket minus 1 to the power of what? 5 plus, what is the next term here now? So we have 9, 2, we have 9, 2, 4, then into our iota to the power of 6, bracket minus 1, or to the power of 6. Then the next one we have plus 7, 9, 2, iota to the power of 5 into minus 1, or to the power of 7, plus the next coefficient, we have 4, 9, 5, iota to the power of 4, bracket minus 1, or to the power of 8. Then the next one is 222. So we have here plus 220 into our iota 3, the bracket minus 1 to the power of 9, plus, then the next one we have 6 iota to the power of 2, bracket minus 1, or to the power of 10, there, plus, the next one is 12, okay, our iota, the power of 1, okay, so minus 1, or to the power of 11, and lastly, the coefficient is 1, and we're going to have minus 1 only in the system, so we have here minus 1, or to the power of 12. All right. Okay. This is a bit rhetorical, okay, but just to follow it step by step, then we'll get our answer. All right. So what we do here now, the first thing we're going to do here now is to take note of what we have here now for the power of minus 1, or let's work with our iota. Already we brought out the value of our iota for each of the exponents here now. So let's proceed from here. From here, what is iota to the power of 12? Look at it here. It's equal to 1. So we have this to be 1. Okay, then iota to the power of 11 is minus iota. Okay, and here we have minus 1. So minus times minus will give us plus. So everything here will give us here plus 12 iota. We come to this other side now. Minus 1 to the power of 2 will give us plus 1. The iota to the power of 10 is what? Here we have minus 1. So this will give us minus 6. We come to this other side. Iota to the power of 9 is what? Your iota, positive iota. And here we're going to have minus 1 from here. So here we're going to have minus 22 iota. Remember we said iota to the power of 9 will give us iota. Hence this iota will still reflect here. Okay, so we come to this side. Iota to the power of your 8 will give us what? Positive 1. And here we have positive 1. So everything here will give us what? Plus our 4, 9, 5. Good. Plus, let's come to this term now. Iota to the power of 7 will give us minus iota. And this will also give us minus. So minus times minus will give us what? Plus. So here we now have here plus 7, 9, 2 iota. Again, we come to this other side. Of course, this will give us positive. The iota to the power of 6 will give us what? Minus. So here we have minus, minus 1, right? So we have minus 9, 2, 4. We come to this other side here. Here we have iota to the power of 5 will give us iota. Then here will give us minus. So automatically this will give us minus 7, 9, 2 iota. Okay, then we come to this other side. Iota to the power of 4 will give us positive 1. And here to the minus 1 to the power of 8 will give us what? Plus. So automatically, this will give us plus. So we have this to be plus, where are we? 4, 9, 5. Then we come to this other side here. Iota to the power of 3 will give us minus iota. Then minus 1 to the power of 9 will give us minus 1. And so this will give us plus 2, 2, 0 iota. We come to this one. We are almost there. Here we have iota to the power of 2. What we have there? Minus 1. Then if we have minus 1, this will give us positive. Right? So this will give us a minus 6, 6. All right. Then we come to this iota to the power of 1 will give us iota. The minus 1 to the power of 11 will give us minus. Right? So from here, we're going to have this to be minus 12 iota. Then the last one, minus 1 to the power of 12 will give us positive 1. So we have here plus 1. All right. I'm sweating, man. Okay, but we'll get there. So let's erase this so that we put our final answer here. All right, so now let's take the last lap to this challenge here now. Okay, so let's have here equal to, mind you, it is our expression we have here now. So let's bring down the expression, bracket here, your iota there, plus bracket, your minus 1 or in bracket to the power of 12 will now be equal to what? So we have here 1, let's go down, minus 66, plus 495, minus 924, then we shall do one again, plus 495, and minus 66 plus 1. If you use your calculator very well, that will give us minus 64. So we have this to be minus 64. Then let's come to our terms that are carrying your iota. So we have this plus 12 iota minus 222 iota plus 792 iota minus 792 iota. Okay, mind you, this and this, they will leave the system to make the work easier. This and this will also leave the system. Remember? Okay, then this and this will leave the system. So at the end, we discover that our iota will leave the system. So we have the whole of this expression. This is the answer to it. 64 is the answer to this expansion. Yeah, now, if you expand this, it will give you minus 64 rather. Okay, so minus 64 is the final answer. All right, so this is a bit tough, but at least we have the final answer here. If you learn something from this expansion using the Pascal triangle and alongside with our iota here, the value here, the arrangement, whatever. If you learn something from this, do not fail to give this video a thumbs up. Okay, and if you learn something from this, just drop it in the comment section without hesitation. Say it could be thanks Jay, well done Jay, for what you've done so far. Okay, yeah, we are here to roll out more challenges. Again, if you have a better way of solving this challenge, of expanding this, do not hesitate to put it in the comment section, because we also want to learn from the best brains all around the world. Remember, this is Olympiad TV, and my name remains Jigs Anemo. Every one of us at Olympiad TV loves you. I love you the most. Bye for being there right from the beginning to the end of this challenge.